All right, so I want to go ahead and actually work on this problem here. We made this 4.00 seconds in class. Let's go ahead, write down the position equation for this car. So we have S equals V times T plus the position that it started at. Now, to be clear, we actually need to get this rate, which is going to be delta S over delta T. And in this case, that's going to be 60 minus 20 over the 4.00 minus 0.00. When we actually solve for that, we're going to end up getting 10.0 centimeters per second as our rate. So S is going to equal 10.0 times T, and we start off at the 22nd position. And we wanted to know how far it'll be after 8 seconds. So when we actually solve for that, S is going to be 10.0 times 8.00 plus 20. And we end up actually getting 100 centimeters. And if you wanted to show this on a ruler, I draw like one ruler, two rulers, 0, 100, 200, and I would just show this kind of miserable car hanging out here at the 100-meter mark. Now we're going to plot position as a function of time, and let's be careful about this. So yeah, I'm comfortable going out to 10 seconds, so we can say like 2, 4, 6, 8, 10, 12, 14, and we'll just count by tens here, so 10, 20, you know what, no, actually, 20, 40, 60, 80, 100, 120, and again, so we got 2 seconds, 4, 6, 8, 10, 12, 14, let's be clear, 2.00, 4.00, 6.00, 8.00, 10.00, 12.00, 14.00. And here we're going to have 20.0, 40.0, etc. 60.0, 80.0, 100, 120 with the decimal, and 140 with the decimal. And again, this is position versus time. And we got to label these units, so this will be time in seconds, and this will be centimeters in, sorry, this will be position in centimeters. Now let's go ahead and graph. So we start off at the 10 centimeter mark right here at 0. And then we're advancing at, sorry, we're starting off at the 20 centimeter mark. And I'll do it in a different color. And then we're advancing at a rate of 10 centimeters a second each second. So we just kind of continue drawing along here. It's a fairly straightforward graph, nothing amazing. If you notice at 8 seconds we land up at 100 exactly like our equation predicted. Then we go ahead and draw, just like that. Now, continuing with similar logic, let's do the velocity graph as a function of time. And here we need to have our labels here. Now my velocity, my slope is 10 centimeters a second, so I'm going to try to go up to maybe 10 on this graph. So I'll say 2.00, 4.00, 6.00, 8.00, 10.00. Sorry, my labeling's so bad. And then 12.00 here, 14.0. So it should be 10.0, and then 12.0, and then 14.0 here. So this is velocity in centimeters per second, and we'll go with time here, so 2.00. 8.00, 10.0, 12.0, 14.0. There we go. And this is time in seconds, and this is velocity versus time. We never change our speed, so we're at 10 centimeters per second when we start, and then that speed never ever changes. So we just have a flat line going all the way across here. So I wanted to give you an example of how we do the first problem, and I hope you'll use this as a basis for finishing the homework.